Hi everyone. In this video, we're going to be looking at solving absolute value inequalities. So this is similar in a lot of ways to how we were solving other types of inequalities. And of course, it has a lot of the same characteristics as solving an absolute value equation. In fact, we start there. With most of our inequalities, we started by figuring out what were our domain critical values. But with absolute value, we don't have domain issues because an absolute value function has a domain of all real numbers, unless there's some other characteristic like a square root or a rational involved in it. So we start by solving the equation, the absolute value of x minus 2 is equal to 5. In this case, any solutions to this equation are also solutions to the inequality because I have less than or equal to 5. But that's not necessarily the case. I'm still just going to solve the equation. Now, when solving an absolute value equation, we do have critical values related to the absolute value. We've got to be clear and careful here. The critical value here of x equals 2 is not a critical value necessarily for the inequality. It's just what we need in order to solve the equation. So x equals 2 divides our number line into two partial domains. We have the interval where x is less than 2, and we have the interval where x is greater than or equal to 2. And we look at what happens to the absolute value of x minus 2 on either side of that divide. If x is less than 2, then x minus 2 is negative. So the absolute value of x minus 2 is the opposite of x minus 2. If x is greater than or equal to 2, then x minus 2 is already its own absolute value. So x minus 2 here, which means that to solve this equation, we actually have to solve two different equations for each of these intervals. For the first equation, we have the opposite of x minus 2 equals 5. This is for the domain where x is less than 2. And for the second equation, when x is greater than or equal to 2, we're solving the equation x minus 2 equals 5. So when I do this, negative x plus 2 equals 5, so negative x equals 3, x equals negative 3. Negative 3, I check, is in fact less than 2. So that is a solution to the equation that I must accept. It's not an extraneous root. In this case, I get x equals 7, which again is an acceptable answer because 7 is greater than or equal to 2. So both of these solutions work. They are therefore solutions to the equation, and it is the solutions to the equation that give me my critical values for the inequality. So my critical values for my inequality are at negative 3 and 7. 2 is no longer a critical value. 2 is a critical value to solve the equation, but it's irrelevant for the inequality. The only ones I care about are the solutions to the equations. Negative 3 and 7 are part of the solution to the inequality because I have less than or equal to 5, and I pick a value in each of these intervals to test. So let's say I test x equals negative 6, x equals 1, and x equals 15 as an example. So the absolute value of negative 6 minus 2 is the absolute value of negative 8, which is just 8. 8 is not less than or equal to 5. So this interval is not part of my solution. The absolute value of 1 minus 2 is absolute value of negative 1 is just 1. 1 is less than or equal to 5. So this interval is part of the solution. And the absolute value of 15 minus 2 is equal to 13. 13 is not less than or equal to 5. So this interval is likewise not part of the solution to the inequality. The inequality solutions are found in the central interval here, and they do include the negative 3 and the 7, as I mentioned previously. So overall, the solution to this inequality is x is in the interval inclusive of negative 3 and 7 between them. That is therefore the solution. That's the same overall process to solve any absolute value inequality. The complexity of the absolute value inequality basically depends on the complexity of the absolute value equation that we have to solve. How many different intervals is it broken into? How many different equations do we have to write? Do we have extraneous values? Those sorts of things. So we'll look at a few more examples just to see some different levels of difficulty. So let's say now we have x plus 3 is less than, or the absolute value of x plus 3 is less than the absolute value of x minus 4. So I'm starting by solving the equation, absolute value of x plus 3 equals the absolute value of x minus 4. I've got two critical values here, where x equals negative 3 or where x equals 4. So that divides my number line into three regions. I have values of x that are less than negative 3 values of x that are greater than or equal to -3 but still less than 4, and values of x that are greater than or equal to 4. So I look at what happens with each of these absolute value expressions in each of those intervals. X plus 3 is negative if x is less than -3. So for the first interval, the absolute value of x plus 3 is the opposite of x plus 3. And for the other two intervals, it just is x plus 3. X minus 4 is negative if x is less than 4. So for the first two intervals, I'm going to have the opposite of x minus 4. And then for the third interval, I've got just x minus 4. So this defines three different equations. My first equation is if I have the interval x is less than -3. That is where I have negative x plus 3 is equal to negative x minus 4, which I can drop the negatives and this just becomes x plus 3 equals x minus 4. Those x's cancel off and I end up with 3 equals -4, which is obviously nonsense, so there are no solutions in this interval. Now at this point, and this will happen in some special cases, at this point I'm actually going to jump over to equation 3 because I notice that my second step of equation 1 actually just looked like equation 3. X plus 3 equals x minus 4. So in this case, not in many cases, but sometimes, a couple of the equations actually end up being the same equation. So this also gives me the gibberish that 3 equals -4, so I also have no solutions in this interval. So this was the interval where x was greater than or equal to 4. So the first equation and the third equation turn up no solutions. The second equation, where I have x plus 3 equals the opposite of x minus 4, so in other words, x plus 3 equals negative x plus 4, so I get 2x equals 1, x equals therefore 1/2. I do get a solution. I have to think about whether it's extraneous or not, so this is the interval between -3 and 4. 1/2 does lie in that interval, so I do get a solution to this equation. 1/2 is not a solution to the inequality though, because when x equals 1/2, the absolute value of x plus 3 is equal to the absolute value of x minus 4, but I want to know where it's less than. So I'm going to take that 1/2 and it will become a critical value for the inequality. 1/2 is not part of the solution, but it's the boundary. So now I'm considering what's happening on either side of that boundary, and I'll just take a test value. So let's say x equals 0 and x equals 100. I could pick 1, I could pick any number that's greater than 1/2. So what happens if I take the absolute value of 0 plus 3 and I compare it to the absolute value of 0 minus 4? Well, on the left-hand side, I have 3, so the absolute value of 3 is 3. On the right-hand side, I have the absolute value of -4, which is 4. 3 is less than 4, and that's the sign I'm looking for, so this is the interval this interval does count. If I test the other one, absolute value of 100 plus 3, compared to the absolute value of 100 minus 4, this is 103 on the left and positive 96 on the right. 103 is not less than 96, so this interval is not part of my solution. So the solutions are everything to the left of 1/2, but not including 1/2. So x is in the interval from -infinity to 1/2, not inclusive. So looking at another one, this time all three equations will be distinct, and the reason that happens is because we have that constant of 3. So looking at this, I'm going to be solving the equation, absolute value of x plus 2 plus the absolute value of x minus 1 is equal to 3. So I have two critical values here where x equals -2 and where x equals 1. Remember that solutions to this equation are not going to be part of the solution to the inequality, but I need to find them anyway. So I've got three regions here again. X is less than -2. X is greater than or equal to -2, but still less than 1. And x is greater than or equal to 1. So for the absolute value of x plus 2, it's going to be the opposite if x is less than 2. And it's just going to be x plus 2 for the other two regions. And for the absolute value of x minus 1, it's going to be the opposite for anything less than 1. So that's the first two regions. And then it's going to be just x minus 1 for that last region. So three different equations, 1, 2, 3. And let's look at what happens. So for equation 1, we have the opposite of x plus 2 plus the opposite, so in other words, just minus x minus 1 equals 3, minus x minus 2 minus x plus 1 equals 3. So that's negative 2x is equal to 4, x equals negative 2. Well, this is the interval where x is less than negative 2, and I didn't include the negative 2 here, so technically this solution doesn't work. But when I see a boundary point, I'm expecting something strange to happen in the middle. So for the second equation, I've got x plus 2 minus x minus 1 equals 3. So x plus 2 minus x plus 1 equals 3. The x's cancel, but unlike the previous case where the x's canceled and I got a nonsense equation, this ends up being 3 equals 3, which is true. So that means it's true for all values in the interval. And this interval is inclusive of the negative 2, but not of the 1. So this one is true for the whole interval. So true for the interval from negative 2 to 1. Now, again, not including the 1, but this leads me very heavily to suspect that in the third equation, I should get x equals 1 as my answer. So let's go ahead and see if this is true. So for the interval x is greater than or equal to 1, we have the equation x plus 2 plus x minus 1 equals 3. So 2x is equal to 2, x equals 1. I am shocked. X equals 1 is actually in this interval, so we accept it. And that means now that the solution to the equation is the entire interval from negative 2 to 1, inclusive of both endpoints. These are the points where the absolute value of x plus 2 plus the absolute value of x minus 1 is actually equal to 3. But those are not solutions to my inequality. It does, however, give me the critical values for my inequality. And in fact, here, the critical values for my inequality are the same as the critical values for each individual absolute value. So testing a point, I don't really need to test a point between negative 2 and 1. I'll explain that in a second, but I'm going to. So if I test x equals negative 6, let's test x equals 0, and let's test x equals 3. So if I test, so remember the negative 2 and the 1, they are solutions to the equation, but they are not solutions to this inequality. So if I test negative 6, I've got the absolute value of negative 6 plus 2, plus the absolute value of negative 6 minus 1. So I've got the absolute value of negative 4 plus 2, or sorry, negative 6 plus 2, which is negative 4, absolute value is 4, plus the absolute value of negative 7, which is 7, that's 11, and 11 is greater than 3. So this interval is acceptable. If I test the interval greater than 1, so I'm going to skip all the way over to the far right interval, if x equals 3, I've got the absolute value of 3 plus 2, plus the absolute value of 3 minus 1. That's 5 plus 2, which is 7. 7 is also greater than 3, so this interval is acceptable. So far, I know that I need to choose the two outside intervals. Now, the reason I don't technically have to test anything in the middle, in between negative 2 and 1, is because I already know that between negative 2 and 1, no matter what value of x I plug in here, I should get 3. That's where it's equal. And I don't want where it's equal, so I actually can't include this. But even if I don't sort of think that through and realize it, or if I'm uncertain because something wonky is happening and I want to test it, if I plug in 0, 0 plus 2, so the absolute value of 0 plus 2 is 2, plus the absolute value of 0 minus 1, which is the absolute value of negative 1, which is 1, 2 plus 1 equals 3. 3 is not greater than 3, so I can't include this interval. So that means that the solutions to the inequality are all the values of x that go from negative infinity to negative 2, not inclusive, and from 1 to infinity, not inclusive. One small change on this inequality, if I changed it to greater than or equal to 3, then in point of fact, absolutely every real number would be a solution to this inequality. If I changed it to less than 3, then there would be no solutions. So all of these things are possible. Now let's look at one more that kind of looks like it's going to be a little more complicated because we have fractions, but it's actually not. Because what I notice is both of those fractions have a denominator of 2 that is a positive 2. So I can multiply this entire inequality, both sides of it, by positive 2 without really impacting anything. Because I'm multiplying by a positive number, I don't have to swap the inequality. And because I'm multiplying by a positive number, I can distribute it into the absolute value. So this now becomes the absolute value of x plus 1 plus the absolute value of x plus 3 is greater than or equal to 6. So now I can solve that inequality, and it's the same as solving the original inequality. So now when I solve my equation, absolute value of x plus 1 plus the absolute value of x plus 3 equals 6, solutions to this equation will also be solutions to that inequality because I have greater than or equal to. I've got critical values at x equals -1 and x equals -3. So that's going to give me 3 different equations as usual. So -3, -1, I've got when x is less than -3. If that's the case, then the absolute value of x plus 1 and the absolute value of x plus 3, they're both negative numbers, so they both have to be their opposites. Opposite of x plus 1, opposite of x plus 3. For values between -3 and -1, in this interval, x plus 1 is still a negative number, so the opposite of x plus 1. But x plus 3 is now a positive number, so absolute value is just x plus 3. And in the final interval where x is greater than or equal to -1, they're both already positive. So just x plus 1 and x plus 3. So here's my 3 equations, 1, 2, 3. First equation for values of x less than -3, we've got the opposite of x plus 1 plus the opposite, so minus, gotta erase that, and for some reason my eraser isn't working. See, it's just like being in regular class. So minus x plus 3, I want to know when that's equal to 6. So -x minus 1 minus x minus 3 equals 6. -2x is therefore equal to 10. X equals -5. -5 is in the interval where x is less than -3, so it is an acceptable answer. It's a solution to the equation. It is therefore also a solution to the inequality. Going on to equation 2, I've got the opposite of x plus 1 plus x plus 3 equals 6. We're going to see this happen a lot. I've got x's that are going to cancel out. But this time I have to be careful of whether I get something true or not. So when those x's cancel, I get 2 equals 6, which is not true. So no solutions in the interval between -3 and 1. And finally, for the third equation, values of x greater than or equal to -1, I've got just x plus 1 plus x plus 3 equals 6, which is 2x equals 2, which is x equals 1. 1 is definitely greater than -1. So this solution is also acceptable. So for the equation, I've got the solutions -5 and 1. Those are therefore my critical values for my inequality. And they are also solutions to the inequality because the equals is included here. So testing values, let's say x equals -100, x equals -2, and x equals 2 as an example. I can test in either the original one that had fractions or the one where I've gotten rid of the fractions. So I'm going to go with the one where I got rid of fractions. So I've got the absolute value of -100 plus 1, which is -99, plus the absolute value of -100 plus 3, which is -97. So 99 plus 97 is in fact greater than or equal to 6. So this interval is just fine. If I'm testing x equals -2, I've got the absolute value of -2 plus 1, which is -1, plus the absolute value of -2 plus 3, which is 1. And so 1 plus 1 is 2, which is definitely not greater than or equal to 6. So 1 plus 1 is not greater than or equal to 6, so this interval isn't included. I expect, because you start to notice patterns, that this next interval will be included, but you need to check. So I've got the absolute value of 2 plus 1, which is 3, plus the absolute value of 2 plus 3, which is 5. 3 plus 5 is also greater than or equal to 6, so that is included, which means that in this case, the solutions to the inequality are everything to the left of and including -5, and everything to the right of and including 1. So in other words, x goes from negative infinity to negative 5 inclusive, or from 1 to infinity. All right, so you can find practice for these in a worksheet in D2L about absolute value inequalities, and also on the absolute value worksheet from before with functions and equations, there's also questions 13 to 18, which have absolute value inequalities.